Good morning, students. Today I am going to start electrostatics. Now, let me first tell you, electrostatics is a very important branch of physics. Okay, as you know, electrostatics, okay, is actually static electricity. Okay, so let's come to the point. Today I am going to teach the first chapter of electrostatics, which is Coulomb's law. Okay, Coulomb's law. Now, what is Coulomb's law? What is Coulomb's law? Coulomb's law states that the force between 2 point charges is directly proportional to the product of the magnitude of the charges and directly proportional to the square of the distance between the 2 point charges. I repeat once again, students, Coulomb's law states that the force between 2 point charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. Okay, now children, please follow me. Okay, let the point charges be denoted by Q1 and Q2. Okay, and let the separation of distance be R. So you see, students, the 2 point charges Q1, Q2, the force between the 2 point charges R, and from Coulomb's law we have F proportional to Q1, Q2 by R square. Okay, so from this relation we can see that the force between the 2 point charges is directly proportional to the product of the magnitude of the charges, okay, and inversely proportional to the square of the distance between them. Understood? So, F proportional to Q1, Q2 by R square, or F equal to K Q1, Q2 by R square, where K is a constant of proportionality. Okay, so F proportional to Q1 Q2 by R square, or F equals to K Q1 Q2 by R square, where K is a constant of proportionality. Now this K is also known as Coulomb's constant. I hope you have understood, students. Now let me tell you one more thing, students. F stands for the force of attraction. Okay? Now suppose over here Q1 is positive and Q2 is negative. So there will be force of attraction. If Q1 is positive, Q2 is positive, then there will be force of repulsion. Okay? Again, if both Q1 and Q2 are negative, then again it will be force of repulsion, because we know very well that like charges repel and unlike charges attract. Okay, so if the two charges are of similar nature, there will be force of repulsion, and if the two charges are of opposite nature, there will be force of attraction. Okay. I told you that F equal to K Q1 Q2 by R square. Now in SI system, okay, in SI system, F equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. Okay, please take a look at this. F equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. Okay. Now you will ask me that what is the value of 1 by 4 pi epsilon naught? Okay. The value of 1 by 4 pi epsilon naught is 9 into 10 to the power 9. Is that understood? I repeat once again, the value of 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9. Okay. Now, how to determine the value of epsilon naught? Okay children, first I will show you how to determine the SI unit of epsilon naught. Okay, the SI unit of epsilon naught. See, 1 by 4 pi is a constant. You know the value of pi. The value of pi is equal to 22 by 7, which is a constant. So 1 by 4 pi is a constant. Okay. What is the SI unit of force? The SI unit of force is Newton, right? And the SI unit of charge is Coulomb. Okay. So we see it will become Coulomb square. Okay. Coulomb into Coulomb will give you Coulomb square. And what is the SI unit of distance? The SI unit of distance is meter. Understood, students? And what is epsilon naught? Epsilon naught is the permittivity of free space. Is that understood, students? Epsilon naught is the permittivity of free space. Okay? Free space means vacuum. Okay, students, thank you so much.